So we're going to use matrices to do this, but let's look at the question. Find the image of the unit circle under a dilation factor of 2 from the y-axis, followed by a rotation about the origin 90 degrees anti-clockwise. Now, you can do that fairly easily. We have a unit circle, which means that it's around the origin, 1, 1, negative 1, negative 1. Let's see, under a dilation factor of 2 from the y-axis. So what we get is a new shape called an ellipse, and our ellipse passes through here and here and looks like that, and then followed by a rotation about the origin 90 degrees anti-clockwise. So now I take that object and I spin it 90 degrees and I'll get something that looks like that. And that's going to be my final answer. An ellipse that passes through the x-axis at negative 1, 1 and passes through the y-axis at 2, negative 2. Now we're going to do that entire thing with matrix transformations because obviously, you know, not all the questions are going to be quite as easy as that. Now, first things first, I need to know what the equation of a unit circle is. You should already know that. The equation of a unit circle is x squared plus y squared equals 1. Alright, so that's a good start. We'll put that aside. We'll use that later. Now, we've got two transformations going on, so we have a nice little formula here. The image is equal to transformation 2 times transformation 1 times the original object. Now we need to figure out what those transformations are. Transformation 2, I'll come back to in a minute because I need to think about that one. Transformation 1, under a dilation factor of 2 from the y-axis, that means that the x-coordinate's going to double, so 2, 0, and the y-coordinate's going to remain the same, 0, 1, and that's going to be multiplied by my object, which is simply xy, and it's going to result in an image. Now I need to think about this. I might need to refer to my formula sheet. So, cos 90, sine 90, negative sine 90, cos 90, that's how I'm going to rotate this thing. Now, all of those numbers are either 0 or 1, and then I'm going to take those numbers and multiply them by those numbers. Okay, so cos 90 is equal to 0, sine 90 is equal to 1, negative sine 90 is equal to negative 1, and cos 90 is equal to 0, and I'm going to multiply that by 2, 0, 0, 1, and I'm going to multiply that by x, y. Now, you should pause the video, you should do it. I'm just going to do it in a single step. Alright, I'm going to hold there, and I might just do this last step on camera. I've just multiplied those two together. Now, 0 times x is 0, negative 1 times y is negative y. So we get negative y there. And 2 times x is 2x, 0 times y, and I get 2x there. Now what that means for me is that x dash is equal to negative y, and y dash is equal to 2x. So now I need to rearrange those to make x the subject. And it's kind of an interesting question here because usually x is in the top line, but it's not. It's here in the bottom line. So I can rearrange that one and rearrange that one. So rearranging this one, we get y is equal to negative x. And rearranging this one, we get, or x is equal to the image of y over 2. And now I can take those two and sub them into my original formula. So, x is y dash on 2. And we're going to square it. So I'm putting y dash on 2 in for x. And I'm going to sub in negative x here. And I'm going to square that. That's going to be equal to 1. That looks pretty good so far. I can probably just fix this up a little bit, do y dash squared over 4, and just make this bit a little bit neater because negative x squared is going to be the same as x squared. Now, do we need a bracket? No, we don't need a bracket. Alright, if you were to sketch this ellipse, you would get the ellipse that we showed in the beginning of the video. So, that's a transformation of an ellipse. We can do it with absolutely any graph we want. We might even do it one more in a future video. Just so I don't leave that little thing behind, y squared on 4 plus x squared equals 1. We don't need our little image notation in our final equation.